Acceptance.
Wow, we need something like this on the Wrocław Jargon. Hello, everyone, and welcome after the lunch, after the one presentation. Do you like it, Piotr talk? It was nice, yes? So now we go to the funny talk. And at the beginning, I would like to say one important thing. Most of the code that you see today in this talk is do not. Do not use that on your commercial projects. Do not use that code on your private projects. Do not use that code ever, never. Yes, I write this code just because I want you don't write this. Yes? Okay, this is first thing. My name is Bartek Kuczyński. I came here from Wrocław. I have a blog. I have talks on that blog. Lot of stuff. And at the beginning, I would like to ask one question. Who knows what is a role-play games? Okay. Who played role-play games? Computer doesn't count. Paper one. Okay. So this is this problem. Okay. Let me introduce Doric Hexhammer. This is a dwarf warrior engineer, and because they have two classes, yes, so they must be on the level 20 in the Dungeons and Dragons. Yes. Who knows the Baldur's Gate? Okay, it's good. He's level 20, and they start his first job as an engineer. He's a Java developer, Java engineer, so very junior Java engineer. So they have a task to write some specific system that use a concurrency, and they need to use all those stuff that we know in the concurrency. So we have a name, we have a class, we have a race of this hero. Time to alignment. This table sometimes happens in the internet. People put different stuff there. And in the Java world, if you would like to be true neutral, you use a synchronized. Why? Because this is a language level. This is keyword, yes? All Java keywords are valid in Java code. If you would like to be a lawful and good, you use immutability. Yes, immute everything. You use events. Yes, all the mutation is the event that create a new object, or you register that somehow. Technically, you push all the problems with changing the stuff to some kind of the library. If you are good but neutral, you try to use atomics. Yes, for numbers, sometimes for objects. It's quite good. It's okay. This is part of the standard Java API. Everything that is in the language API is okay. Yes, you can use that. If you would like to introduce some chaos, if you are an artistic spirit, yes, somewhere in deep, there is a small cobble that say you should go to the ISP, yes, for the art academy, not to the IT. Use eventual consistency. As this is a piece of art. If it's good, it's a piece of art. If you are okay with the law, but would like to be a neutral, you use a locks. They are better than synchronized. They are faster, they are easier to use, and they are still part of the API. But if you like chaos, you use a treat sleep. Yeah, who uses a treat sleep? If you write this dummy test, I would like to see what happened. Yeah, this is the small cobalt say, go to Art Academy. If you okay with the law, but you are evil, yes, you are like a developer, not like a IT developer, but the building developer, and you say this is correct with the law, but it's a bad thing by general, then you use treat yield. Yes? If you combine that with the treat sleep, it's everything okay. Yes? This is bad thing. We shouldn't use that. Yes? Neutral and evil, it's a single treat. Technically, it's like a good, lawful good. Yes? We don't have a problem with synchronization if we don't need the synchronization because we are sure that only one thing happened in one moment. Single treat everything. It works. But if you like a lot of chaos and you are evil, you use a possible consistency. It may be correct. Yes, this value is maybe correct, maybe not. Fun fact is that I know one system in this country that used that approach. Why? Because they need a trend. They have a lot of data, but they need to take a look to the trends. Yes, if I know that the value will grow or will fall, it's okay until it's more or less consistent. Yes, I don't care about exact value. I need to know the trend. Yes, the change. Okay, we have alignment, and we start from the neutral. Yes, true neutral. The motivation. Okay, why we need to use the synchronization in our applications? Yes, this is quite important because there are few different approaches, few different reasons. First reason is our data protection. Yes, we have we need to protect our code for some reason. Yes. We know why we do that, yes, because this is account balance. I will back to this bank examples a lot today because it's a quite well-known domain in the concurrency world. I need to synchronize that balance, yes. I know that is my data. I can trace all the changes in the code and all the changes in this data. I know everything. Yes, this is a white box, like white box testing. On opposite side, we have a clients and services. Yes, probably in the JDBC specification is that the classes are not treat safe. Yes, the connection is not treat safe. This is example. We need to protect external client, library, whatever. Yes, we have old, ancient transaction system that is written in COBOL, and they can handle only one call from us as a client at the time. Yes? To do that correctly, we need some kind of the synchronization to limit these calls. Yes, all those pools, etc. Yes, we read the documentation. This is our motivation technically. Yes, so, and someone in the documentation say, this code is not treat safe. But we don't know why. Yes? Even if we read the documentation. Who read the documentation? Don't lie. Technically, someone, right, okay, use some kind of the synchronization if you would like to use that code in the multi-thread environment. It's a black box. Probably it's a mimic. Yes? Who knows the mimic? Yay. They try to mimic something else. This is our treasure box, but in real it can eat us. Happens. Third group is a process, something bigger. Long-running, multi-step processes. Yes, mostly in Java nowadays we use streams for that. Yes, because we process some collection, so it's easier to use streams. Some elements could be run in parallel, some need a synchronization, some need to be run in the single thread. So this is something where we need to coordinate. Yes, we need to some kind of the control to say, okay, we need to send an email. Yes, nowadays we often use events for that. Yes, we wait for the event or something like that. It's a gray box. Technically, we know something about that, not everything, especially if a process is very, very complicated. So, let me introduce the enchanted land of the synchronization, and let me be your guide. It will be funny. Yeah. Okay. Single object synchronization is pretty easy. Let's say we have account, we have deposit withdraw methods. Yes, we write the synchronized keyword, everything is correct. Who have a problem with that code? Yes, there is a problem, exactly. But we will go forward. Remember, Doric is his first job with that space. There will be a lot of fun. Okay, we could use a monitor. Yes, if we don't want to use a balance as if we don't want to synchronize a method itself, we can use a monitor. Yes, so some object that exists and we synchronize over this object. And quick reminder, yes, synchronize of the object is a monitor. Synchronize on the method is more or less like synchronization on this. Yes, this is a monitor. Synchronized on the static method, this is a shortcut, yes, because technically they take a class, but they synchronize on the object that represents a current class. Okay, pretty simple. Congratulations, you finished the tutorial. At this moment, most of people who learn Java from the scratch, they know how to work with the multithreading. Yes, they have a synchronize and a few extra methods. Many object synchronization, multiple object synchronization is a little bit more tricky. Let's take a look to this code. We have a bank service. We have a simple account that has a deposit, withdraw, some validation. Yes, it works. Now, I would like to implement something that is called bank problem. Yes, we have a Bob, we have a Alice. They have some money, and in one thread, Alice send the money to Bob. Bob send the in another thread. Bob send the money to Alice. Obvious? Great. Whole problem happened here. Yes, we have two things that works in the same time. Yes, two threads start here need to be coordinated, not synchronized, coordinated somehow. The easiest method to do that is a method level synchronization. Yes, I have account from account to value to transfer. Yes, withdraw deposit, it works. What is a problem with that code? No, not the race condition. There is only one object that is synchronized here. This is this synchronization. Yes, from the tutorial. From and to are not synchronized. No way to synchronize them here. Yes, the monitor is a method sync instance. Yes, so the instance of this bank service. So if I have common Spring application that have only singletons, it will be works. Slowly, but works. But if I have application that have multiple instances of the method sync class, multiple objects, each other is synchronized by themselves. Yes? So they are independent. Sorry, you that. Okay. So maybe we need these types of synchronization over the parameters. And this is a race condition. Yes? Because Alice sent the money to Bob, so Alice is locked first, Bob is locked second on the first read. On the second read, Bob is sending money to Alice, so Bob is locked first and Alice a second. Yes, in the bad timing, these two threads lock Alice and wait for the Bob, because the Bob is locked and the other thread wait for Alice. Yes, simple. So we are dead once again. Yes, beholder. I look at you, you look at me. Yeah, and we wait. And we wait. We have a problem. Okay, now the thing that is horrible, but has that internal beauty. What is the problem with this code? The problem is the order of the achieving a locks, yes, or synchronizing, because a lock is pretty the same problem. So if only we could be sure that always we log this object in the same order. Yes? So let's use a comparator. Remember, we have a junior developer, and this is real code. I know that. Yes, I wrote that 20 years ago. Yes, and it works. And to be honest, if previous version was a beholder that just can watch it on you, this is a mandragora. Yes, you are dead. Dead. Yes? But we can make it better. A little bit better. No, we cannot. Only thing that we can do with that previous code is add the generics. Yes? Horrible, yes? Pure house. I like it. Don't do that on your production, on your private products, on your mind. This is a black magic, and it works. Problem is that this is only 2 parameters here, yes? And we need a B function to compare them, yes? If we have 3 parameters, we need more and more this comparator size thing, yeah, to be sure. So if we introduce that into our project, we meet our colleagues from project, yes? This is your team after the code review. They try to find you and kill you. We are in, yes? This is a good place. So, congratulations, you level up. You know what to not do, what don't do, yes? Do not. Don't do that. Don't try to do that. Don't think about that. Yes, let's teach ourselves on mistakes of the other people. So, let's try another path in that dungeon. Let's, Doric, if they have the level up, now he have a new skill, the aspect. Who knows the aspect-oriented programming? Who remember when the aspect J happened? That was nice, yes? That was a brilliant moment. We have the aspects. We can create a clean code and put that aspects everywhere, and our business code doesn't have log info line anyway, yes, because we have these aspects. No. Let's define the annotation. This is a second try, and this one will be harder. We have extended log. So if the problem is the parameters and order of the parameters, let's say, okay, I would like to log all the parameters of the method, yes, and store them somewhere and say, okay, this is a storage that say what cannot be change during this call, yes, by different treat. Then we add the aspect that has work around every method annotated with the extended lock. Okay, this is easy. In the Spring, it's pretty easier, but this is pure aspect J. And we have a lock handler. Lock handler is something like this. They use the locks, they try to lock, and in the first step, they check if any parameter of the method call is locked. We have a lock map. Lock map contains the information about the locked elements. Yes? If the element is locked, exists as a key in that map, but is locked by another treat, then I cannot lock. Yes? So I return false. But if all the elements are not in the map or are locked by the same treat, by the current treat, I can add the specific entity to this map or increment a counter, because one treat can, this incrementation, this counter is needed to track number of the locks. Yes, because the method can, that is extended lock can call another method that is extended lock. Yes, so now I have two locks of the object. So I need to remove both of those locks from this object. This is more or less how the synchronization in Java works. Yes, but guys from Oracle wrote it smarter. They don't use a simple hash map. And because everything is locked by lock, so this is a single treat. Yes, two treats cannot check and modify that map in one time. It's slow, but I don't care. So, is it works? No. Why? Yeah? Life locks, it's a one reason. But let's think a moment. What we need to kill the dragon? To kill the dragon, you need sword. To make a sword, you need iron. To make an iron, you need a cave. Who plays in Minecraft? Okay, if we need a cave, if we would like to have a cave, we need a mountain. Yes, mountains contains caves. And if we would like to have a mountain, we need a kingdom. Yes, if we like to have a kingdom, we need king. To have a king, technically we need a princess, but let's make it short. We need to kill the dragon. Yes? So this is a loop. All those simple solutions about the synchronizing multiple objects have a cost. Yes? Sometimes it means they are slow, they need extra work, or they introduce very bad code as it is. Yes? So let's try to think about something, some kind of the spell. If there be anything, any piece of software that is good in the modifying multiple values in the one time, yes, at one moment. So there it goes to the library. And what is a modern library in the IT world? Where we store our knowledge. Stack Overflow is just the API. It's a user interface. We need something pretty simple. Exactly. We need a database. Databases are good in the relational databases. Are good in the two things. The database is a great hard driver because they know how to use that tiny magnetic needle to put knowledge in those spinning disk, fast spinning disk, to read that knowledge in the future, in very fast way and efficient way. Yes, this is database, very good hard drive driver. And second thing, more software, it's good in the modifying two things at once. Yes, because they have transactions. Exactly. Congratulations, you level up. Okay, what have a transaction in database? They are atomics, yes? So change goes at once, yes? You cannot break it into the two pieces and say, okay, I execute part of those, then I wait, do something else, execute the other part, yes? No, it's atomic. They are consistent, so the state of the word is correct before and after. Yes, I don't care if that data has a sense, business from the business point of view, but it's consistent from the formal point of view. They work in the isolation. Yes, so one transaction shouldn't see changes from another transaction. We know that there is isolation levels. Yes, but what we don't need in the common programming. This is, you know who is it? Polish guys should remember that guy. Yeah, we have atomic acid without the D, without the durability. Yes, we have a psikutas bez S. Exactly. We don't need that durability because we are not database. We don't need to be sure that we store the data on the hard drive. Yes. If we write something to the object, it's in this object. If machine dead, then that, we lost data. It's not here, yes? The durability is something else. Okay, the new skill is the STM, the Software Transactional Memory. Who knows that term? 1, 2, 3 hands, okay. Let's create the STM account. I'll give you a moment to read that code. Easy? Okay, let's analyze it. First, the ref. The ref is a box that will, where we put a value, yes? That's everything. One important information, I use a closure. This is a software transactional memory implementation from last stable closure. There is few other libraries in pure Java, but the newest one has last commit 11 years ago. So if you are brave enough, everything can go to the production, yes? Everything. Even that code that I showed you before. Okay, how does it work? The magic of transaction happened here. I created something called locking transaction, and I say run in transaction. So I need the transaction to run the change of the balance. Balance the ref has two important methods for us. Set a new value, and the ref that is a read the value. Because it's a closure and it's quite old code anyway, they doesn't use generics, so it looks not good. My question is, if I implement bank service like this, is it correct now? Take a look. I make a change in the transaction. Yes? So I'm pretty sure that only one read can manipulate the balance value. So it's not method sync, it's a no sync bank service. Is it okay? Why? Yes. And this is a mimic. I like it. And this code, this problem happens sometimes in the databases, yes? Sometimes in the Spring. Oh, I put the transaction over some part of the change and run this, and I have another thing that I need to change in the same transaction, but I have another method, and I don't I don't spot that there are two different transactions. Technically, here we have two different transactions. So this code technically do two different transactions, one for the withdrawal, one to the deposit. Because we have two accounts, they are still independent. Nom, 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 nom. You are dead. How to fix that? Pretty simple. First, let's drop transactions from the account, yes, and say, if you would like to modify account, you need to do it in the transaction. There is many different implementation of that. I could use a ref over the account. I would like to use a balance. Why? Because now if I call the withdraw or deposit method somewhere in my code without running transaction, without a run in transaction section, then I will get illegal state exception. And they say me, you cannot do that. Yes? You can't, because there is no running transaction. This implementation guarantees you that you modify two different objects, two independent objects, in the atomic procedure, yes, in the atomic call. Of course, technically, JVM doesn't know that they have a STM, yes? So they could stop this treat between them, yes, somewhere here, and try to call this treat Bob to Alice, yes, this another treat. But this another treat need to wait because they see there is a transaction in the run. I cannot modify those objects. I need to wait. So they will spin wait, yield or give a work away, yes, and Alice to Bob treat will start to continue in this second line. Yes, this is something that we would like to do. Congratulations, you killed the dragon. But what about the processes? Yeah, if you kill the dragon and you would like to go to the processes, it's a little bit different thing. Because synchronization over objects is a very low level. But we don't work with the low-level code, technically. Yes? We work with the processes. This code that we write is just a small part, a small task to achieve something bigger. Yes? So, time to new adventure. And more exps, yes? Maybe. Craziness point. Okay, the process dragon. Yes? The process, the business process, whatever it is, yes, logging to account, sending a money, sending an email, is a big dragon. They have a head, they have a tail. In Java, on the low level, we have something to work with the head of that dragon. We call it semaphore. Semaphore, you could think about the semaphore like some limit of the adventures that dragon can eat at once. Yes, it's like small kid who try to eat all the dumplings at once. This is a semaphore. Mouth is not big enough. We can limit how many treats go into the section. Yes, and say okay, no more treats. We have a tail. A tail is a synchronization of the work. Nowadays, when we have all those streams, we use a parallel streams, fork join pool, this is hide somewhere deep in the code, nearby the class called Balrog. Yeah, we have a two-tail things. Yes, countdown latch. That is just count down, and if the 0 is achieved, then we go forward on the current treat. So the current treat will wait for the 0, or we have a cyclic barrier. Do the same, but we can reset them, yes, and we start counting from 0 to 0 one more time. Okay, but as any type of the passages, yes, there is some trolls. Yes, the trolls keep that, bridges keep that, passages. And problem with the semaphore and latches and cyclic barrier is that they are complicated still. Yes? You need to write this code, you need to maintain this code, and you need to play a little bit with that code, understand what happened. Sometimes this countdown latch is passed from one place in your code to another place in your code, yes? They go through the many levels of calls in the stack trace, and finally nobody knows what happened, yes? Where this countdown latch is released and why. So this is a troll. Okay, but we have phasers. Yes, we have a space dwarfs. Who knows the phaser class in Java? Yeah, you work with the Java 7 probably. That was nice. This is a pretty simple example of the phaser. We have a treat, we pass to the action, whatever it is, a phaser, we register that phaser, and we start. Yes, action itself is something like that. Yes, we are arrived and await for our work. Yes, we do our work. Sometimes we can throw the exceptions, and then we deregister from phaser. We say, okay, we don't need the phaser anymore. The motivation here is pretty simple. We have something that defines the process, and the steps await for each other. Yes, so we have a phases. So it's pretty stupid code, but they have one small thing, that illegal state exception. You die. If we run this code, we have something like that. So, treat 2 starts, treat 1 starts, the ends, the treat 4 starts, treat 3 starts, but there is an exception, and we need to handle it somehow, and this is hard. And this is the place where Java gives us a problem, yes? The old Java, because this is the dead end. Yes, we need to handle exceptions somehow, and it could be thrown by any element of this process. If you work with the reactive stack, yes, and you see that stack traces, long stack traces that say there is a null pointer, yes, and you see that, and that was horrible, yes? But someone wrote the exception handling for that. Now you need to do that by your hand. Not good. This is a dead end. So we level up, and Doric new skill is a structured concurrency. Who heard about that? Yes, this is a new feature that is still, I think, in the preview. I use the Java 21, it's in the preview state. But what we would like to do, we have a pure code, yes? There is no phasers, no locks, no barriers, no everything. Still, we throw an exception sometimes. Now, I create the scope, and I define first 2 tasks, and wait for that task, yes? And if something fails, I will throw the exception. Writing exception handling in this case is a little bit easier, a little bit. I will show you that why. Then I have to next task. I have a scope. Yes, I could define my process and don't care about the exceptions. Yes, I die. But these kobolds say, okay, but you still have exceptions, and you still need to handle that. So what we need here, because we are in a bad dungeon here, yes, we don't make stuff easier, don't make stuff better. And we have enabled preview on production. Polecam. Okay. We need a custom scope. And what the structured concurrency give you is possibility to define your custom scope. And this scope has two methods, technically. We need two methods. First method is handle complete. Yes, if subtask finish with the state failed, okay, I can do something. Yes, I can send a message. I can restart. I can throw exception. I can collect this information. Yes, or restart the task. This is a single point where I write exception handling. And in our code, I just need to use this sandbox as my scope. That's all. It looks better, yes? So you write the sandbox once and say, everyone, we use a sandbox scope. If we have a code that could fail for some reasons. In example, we have an external client who sometimes works, sometimes not work. Simple. And in the custom scope, we see something like that. Treat one starts and ends. Treat two starts and ends. Treat one starts and throw the exception and die. But we continue with this treat 3 and 4. As we handle this exception somehow in one moment and everything is okay. Yes, why not? This is nice. And this is still in the preview. So we, let's say, kill this dragon. But our saga will continue in the future because structured concurrency is still in the preview mode, yes, and software transactional memory is itself. How to implement that is a quite big topic, so maybe in the next year I will back and tell you how to do that in Java, yes, and why not. Okay, thank you very much, and there's any questions here? I don't see. Go to coffee.